Hey everybody, my name is Rick, and welcome to this broadcast. We're gonna make some simple bash prompts and learn what's behind them. We're gonna follow this outline here, which I've admit it's a little bit ambitious, but I think these last sections, we're just gonna lightly cover them and see how far we get. My name is Rick, and let's begin. Let's talk about simple bash prompts. This gist, which I'll put here in our description and also in the chat if you're watching this live, is the code for this exercise. We're going to talk about the prompt command. We're going to look at prompt colors, and we're going to use these simple bash programs that will exercise these things, and we'll take a look at how they behave together. But all that code is available here, so you can try it out at your favorite terminal window. Bash prompts. If you are wondering about the motivation, check out number 8 of this playlist. I talk about why prompts are interesting to me, talk about its history that I've had with it. Really, prompts, as simple as they are, they can give hints as to what you're doing, and that's often helpful. So let's get into this. The manual page for Bash is actually the source of a lot of this material. Prompting is a variable in Bash. It's the PS1 variable. And here on my Raspberry Pi machine, I see that the PS1 is set to this funky thing with Debian chroot, chroot, change root. I wish it weren't there because it's a little complicated to discuss, but just pretty much just ignore this. The core of the prompt is actually all of this stuff here, and we're going to get into all of that in this video. But PS1 is the name of the variable, and here on the Mac it's the same thing. And you can see it's simpler. It looks simpler. It's pretty much the same string, except where I have a 1 here and where I have a 0, 1 here, I just have the number 1 here. So very small differences. Let's take a look at that man page. So here's the man page for Bash. It's I remember when I was eager and excited, I back in the day printed out the manual page for these shells and read them. I think if you were to print this whole thing, it would be at least 20-30 pages. But the section we're interested in is called prompting, and the manual makes references to this section here, prompting. So I'm going to go to it. Here's that section, and there is this primary prompt PS1, and that's what we're going to focus on in this little session here, the PS1, or the primary prompt. And there's all these things that you can display in that prompt, which are preceded by a backslash. So if we take a look at the prompt string, which are these things, you can take a look and see that I have a prompt string here of /u and /h. This signifies, of course, the host name and the username, which is pretty cool. So now I can print my username and host name here with just these variables. So no matter who logs in, if they copy this PS1, it's going to be replaced with their username and their host name. There's only one other prompt string that we're using, which is the W. This thing prints the value of the pwd shell variable with home abbreviated as a tilde. So that's really the echo pwd, which is really the current directory. So if you change directories, you could see that this changes and you always know what directory you're in. Let me go to projects, and I have some code here in my lead directory. I'm going to take a look at a project here, ToSum, and I wonder what's in this PyCache directory. Not too much in here, but you can see that the whole way through I know what directory I'm in. There's an interesting cool trick that I learned from reading the manual page, and you can set the prompt dir trim variable to be a small number, and we can look that up here. Uses the value of the prompt dir trim. I think I might have had it set here, prompt dir trim. Nope. And do I have it set here? Prompt dir trim. I do not. But if I were to set it, export prompt dir trim equal to, what you'll see is that the \w, the prompt string, gets truncated. Your path elements. So if your directory consists of 6 levels of directory paths, all you will see are the last 2. So as we go up, we can see that we are moving up the tree, and finally we have only the 2 remaining projects lead. I was playing with this. I think I liked it, but now that I do not have it set, I wonder if maybe it's just confusing to have ... there. But it's a technique. I thought it was pretty cool that you had that capability. One of the interesting things about the prompt is you can have it do commands for you. Why do we want to do that? Well, maybe you want to know the number of files that are in a directory. Here it would say number 5. What if you always typed in ls pipe wc every time you entered a directory? Well, you can have your prompt display that output, because every time your prompt displays, it will show, or it will run, a prompt command, and you can give as a prompt command that ls pipe w. That's a little, let's actually explore that. And this is where we get into this gist here. There are these prompt colors that are at the top of the gist, but we're going to start doing it with the prompt 1 command. So if I go into this prompts directory and I do prompt 1, we're going to exercise this. We're going to source these files. This is a bash mechanism which allows you to execute the contents of a file one at a time, as if you were typing these things in. It's a little different from a shell script. Sometimes I think is known as a source file, but that can get confusing if you program in compiled languages. But it's simply a file that you source at the command line. So I am going to first, let me split this, and you'll see the behavior when I go and open these files. Now if I go to projects, prompts, if I do the source of this file, which is prompt 1, what I see is that my prompt changes to test 1, but I have this prompt command here, which is actually this command, which is called touch PCI1, and it prints a date. Now, I think everybody here may know that the touch command creates a file in Unix. You could say touch new file, and now there's a new file that's been created. So every time this prompt is displayed, this file is created. And there's the file right here. And now if we were to do this again, we will see that every time we run, every time we display the prompt, we always touch this file. So I'm going to do it one more time, and you can see that this file is always being touched, and by touch I mean it will also update its time. So here the time of new file is 2120, but if I were to touch that file, it would be 2121. So it's been about a minute since the time I created the file. And that's what's happening with this one file here. It's always the timestamp is always going to change, but what you notice is that the file doesn't change, the file name doesn't change, and that might be a problem. You may want the state of your variable or the state of your file to change. So we can address that. There's a new prompt here called prompt2.sh. So I'm going to get rid of these PC1 files, and I'm going to run this command. And the syntax of this bash script is that we're doing PC2 touch as the prompt command. What is PC2 touch? PC2 touch is a function that I've written here in this script file. So if I do prompt2.sh, when I do a listing of the files in this directory, I'm going to see PC2 and then the date. But now if I were to print this again, if I were to just print the prompt again by just running a command, now I'm going to see more than one PC2 file. It's very small difference. And if we just come here, if I just split this out, let me just display the previous file here. This program here, prompt1.sh, this command is set once. It's always executed every time the prompt is displayed, but since it is set once in this variable, the PC1 file name is always the same. In this version in this PC2 version, in PC2, this is a function. So it's set once to that function, but that function is dynamic. It's always going to execute this touch PC2. So every time we run a command and display the prompt here, we're going to see yet another file. Another way to see it that's more apparent is this way. See 6 files, but every time we print the prompt, we're going to get a new file, and it's almost like magic, and it's arbitrary too. So if you go into here and do that command that we were thinking of, how many files are in this directory? We can do it this way, and if I do that prompt again, now you can see that that WC command is always being printed every time we display the prompt. 27 files in this directory, and it stays the same because we're not doing that touch anymore, but we can have more commands in here. A bash function can have more than one line in it. So this is right here is a powerful technique with prompting. You can run a command every time you display the prompt, and that command can gather information that you want to always know about at the prompt. I think this is where people got really fancy with this, and in episode 10, I'm gonna just go on the internet and just find a few fancy prompts, plus talk about the virtual environment from Python and the Git prompt that you get from Git core. So there are definitely some fancy prompts out there that take advantage of this tech capability of bash. I'm going to leave this and go to prompt 3 and introduce another, I think, also powerful capability. Prompt 3, when executed, does 3 commands. How? It has prompt command as an array. It's an array. And in bash, each array is separated by a space. These are double quoted elements. And when you examine this array, you see that it has one function here, PC3 touch. So now we're going to be introducing some PC3 files in here. There's one there, and there's another one because I run it again, and so on and so forth, just like we saw before. But every time we run the prompt, we also do a uname -r and a uname -s, which tells us the release and the system of the machine that we're on. From the powerful idea, you can string together commands not just in one single function, but perhaps in multiple functions using the prompt command. And if you're savvy, and I'm thinking ahead, I haven't looked at any of these special prompts yet on the internet, but I have a feeling some of the fancy ones just append to this array, because you can append things into an array in bash pretty easily. Let's look at another technique. There's a bunch of them here. This one displays the output of a command into a single line. How does it do that? It uses variables. So here, the command is this variables being set var1 to the release of your machine and the system of your machine. So if I run this down here, there'll be this thing going on, prompt 4.sh. So now it's displayed in one line, and it's done using variables. Also, there's this whole concept of the PC4 thing going on. So every time we run the prompt, we're also going to get more than one command. But there's actually an interesting problem with this. It's very similar to the previous one. And that is, if you try to do it dynamically, like say, for example, you have this date and you have a random number. A random is a variable from bash, which prints out a random number. If you do this command here, prompt 5, when you run this command, you see that these variables, in fact, do not change. It's very much the same problem that we saw in prompt 1. The file name doesn't ever change. Here, the values never change. And that's because we're hard coding the command to be something that's executed at the same time. I don't know if I'm explaining that right. We're saying val1 is going to be equal to the output of PC5 date, which is the date. But that date is fixed because that's this this double quoted value is evaluated when it is sourced, meaning this is evaluated once, this is evaluated once, and this value is evaluated once. And as a result, this prompt will always stay the same. 12792, 10464, on and on like that. And so how do we fix that? I thought about this thing here, prompt vars, which is the shell option. That didn't work. But I leave it there for you to experiment with. But if you do use it, make sure to set it back on. Let's go right to the answer. The answer is global variables. It's the answer for everything. And with a global variable, val1 is set up here in the function. And I'm not sure if bash is as fancy as Ruby or JavaScript with closures and global variables. I think it's much simpler. Val1 is a variable, and because it was not declared anywhere, it is essentially global. You'd have to look it up in the bash manual page. I wish I had before this, but now when we run this prompt, every time we display the prompt, the numbers change. The time changes, this changes, but you notice that this does not change because of the previous issues that we had before. The whole exercise of going through those things was just to show that with the prompt command and the prompt command as an array, you have a very powerful technique for executing some functionality every time the prompt is displayed. I'll mention here multiple lines. Very easy to do multiple lines. Just add a multiple line in there. Just put this down here like that. That's a multiple line prompt right there. And I don't know what I'm going to also do is change it to be like that. Now there's a space between my prompt and the %. And this is how I like to roll in my, well, I don't have it here, but I'm using the single line prompt. I'm trying a lot of things. I'm getting excited about the prompts again. I didn't think I would be. I thought I was immune. I thought I was too old, but I'm actually starting to develop some sensitivity to it. And the new line, just simply add a new line here in bash. Again, this is in bash. With the new line, you have a little bit more space, and it's easy to see where your prompts start and end, and it's good that way. But a really possibly better way is to consider using fancy colors. Fancy colors. I'm going to just jump to this gist right here and point out that in In the modern terminals, ones running on maybe your WSL in Windows or your terminal on the Mac. Maybe you have some older computers and you have real old terminals. Back in the day, you could buy a terminal program. I did that for Windows, and I actually did that for the Mac. The iTerm 2 program. But this gist, ANSI escape codes, talks about how to express an escape sequence to tell the terminal to change color. So here are some colors. It's a very simple palette, but you can then tell it to change colors using an escape sequence. Now, I've broken up this gist, and you can see it in the code that I've sent you. In the raw one, this gist shows that we're really passing in numbers, 32, 34, but we put it inside of a particular string, which is the bracket escape bracket sequence. And this is also discussed in this. Nope. I've forgotten where I put it. But you can look up these. Here. You can look up these escape sequences and how you can essentially go into the terminal and tell it, hey, you got to change your color now. And when you do, it will change it dynamically for you. So if I come back here and I run this prompt color test raw, now you have not only color, but you also have bold. There's a bold indicator here, and that's also controlled by, again, these really tough to read escape sequences. But these escape sequences are to some extent, you can simplify these or get around using them by learning this tput command. But I just had some late breaking experimentation, which means I don't want to necessarily recommend this, but when you look at the tput manual page, initialize a terminal or query, you can use this function tput to control the terminal. It's very looks very simple. Here you're getting the output of tput and setting it to a variable, and then that variable you're using it. You're using the value inside of the prompt. So if you were to go down here, I'm going to set this PS1 to be I'm going to set it to be something very simple, like this. But now I'm going to change it to prompt 04 color test tput. You get the same prompt as you had before with bold, but now the way you set it is actually simple. But what I found when you do it this way is, watch this. Echo, this is a long string. Notice how the string kind of just cuts off. And press enter. There's something that I'm pretty sure I'm doing wrong. There's probably another tput that I have to put at the end. In the end, I don't recommend doing it this way because it wasn't clear to me how to honor the width of my terminal. I mean, I have 84 columns here, but every time I type in a long line using tput, you see it cuts off right here. I don't know why, but tput and the commands that it relates to, namely infocmp, these things, if I show it here, infocmp shows the capabilities of your terminal. It decodes the binary term info, terminal capability database, file etc term info, and there's going to, oh wow, read me. You're telling me let's do V. So we have some files here, but these are compiled. But if you wanted to get at what was in here, you can do infocmp to learn about the capability of your terminal. If you're doing this, you're going down a very deep rabbit hole, and one that probably will put you square back into the mid-70s. The thing is, the structures, I guess, and the way to define these terminals are still controlled by these old systems, and understanding this will allow you to create some pretty cool terminal programs. But there are a lot of ways, a lot of libraries now that make that much easier than just throwing in a bunch of escape sequences, namely n curses. But I digress. tput is a way to control your colors, in addition to a couple of other things, but I'm not keen on it because you can't put it into a prompt command and have your terminal work properly. While learning about this, I did find out about, I did put in a little function called color palette. This is based on this repo here, which is I think what I'm going to try to install. We go to this GitHub page. There's this really very fancy prompt. And you can see it's got the ability to display some Git information. That's really what I'm interested in next. But there's also this really fancy display of the palette, the color palette. Whoa. All right, maybe it wasn't this. But if you were to run this little function, you can see the different colors that are possible on your terminal by setting the foreground and the background color appropriately. And here, this thing uses tput, but it's not doing it in a prompt. So at most, this is going to be good for figuring out the colors on your terminal. But then I'm afraid you're going to have to go back and do something like an escape code sequence so that you can, not this one, so that you can use it in a way that's better for the terminal. In much the same way as tput, there is a wrapper program called ANSI. This was open here, and ANSI is a utility. Let me do it this way. Prompt 04. This again uses the prompt command, but here it prints this thing out using a program called ANSI. And ANSI, it can do stuff like, I like this ANSI color. Was it table? Yeah. But with ANSI, you can get a prompt that is workable. So if you do prompt 04 color test ANSI, again, you get the same prompt as before, except it's a little hard coded with the PWD. It doesn't use the -W, which makes the home directory a tilde, but you can express yourself in a way that's a little easier. I just realized this thing, CWD, you don't need that CWD there. It's not being used anywhere. Let's fix that. Now let's just change that in the gist here with ANSI. But ANSI has one kind of issue. And that is when you have your prompt with color test ANSI, if you notice, it actually has a little delay in the display. Let me do that again. Echo hello, and watch how it displays. It's almost like a teletype. It's whatever the program ANSI is doing, and it's a batch program. It's taking enough cycles so that you get this little delay. You might find that charming. I eventually found it a little grating, and ultimately I also abandoned ANSI. So making things cleaner with using something like tput or using something like ANSI doesn't beat escape sequences. So I think we're going to be living with escape sequences until someday they figure out how to revamp terminal internals. Well, we covered a lot here. We just wanted to talk about how to make simple prompts and show you some programs that you can experiment with. The next time I come online, I'm going to have installed like this prompt here. But there's lots of prompts in GitHub. I'm going to pick a few that are interesting. Maybe we'll look at some of their code. But we're just going to casually do a survey, a very brief survey. And if you have a prompt that you recommend, let me know about it. Maybe in a YouTube comment or a GitHub comment, however you want to reach me. And we can take a look at it. I don't know when that will be because there's a lot of televised sports I'm watching, but it'll be sometime soon. I thank you for checking this material out and for looking at this with me. We'll catch everybody next time.